So this is, again, problem 2, and the expectation is that you've done problem 1 and also that you've done problem 2A. 2B is a little bit more complicated, so 2A will help you on this. So we're adding some HCl, but this time we're adding it to sodium propanoate, and we know that that's an acid-base reaction. So the first thing I'm going to look at is adding the acid is just adding H+. I know it's going to react with the propanoate, and it's going to react, right? It's not going to be in equilibrium. I'm just reacting it. And when I make something, it's going to be propanoic acid. So let's look at what happens when I do this. But keep in mind, it's not so much an equilibrium thing that I'm finding. It's the end concentrations I have once I've reacted all my H+. So if I look at how much H+ I start with, well, it's 0.02 molar. If you're not quite sure how to get that, try watching the video for 2A. If I look at how much propanoate I start with, well, I have 0.1 molar sodium propanoate, and if I'm looking at this, I'm actually not starting with any of this. So the assumption with these problems is that all my acid is going to get used up in reacting with as much base as it can. So I'm going to subtract all that acid, and then on this side it will be added. So I get about 0 H+, I get 0.08 molar for the propanoate ion, and then I get 0.02 molar for the propanoic acid. So these are the concentrations I have once all the H+ is reacted. But now this is going to establish some equilibrium. So I'm actually going to do the ice chart for this at equilibrium. So I have C3H5O2 minus in water, and that forms OH minus because it's a base. We did this problem with the Kb, plus the conjugate acid, propanoic acid. And when I look at that, I see that I need to do ice with an initial concentration of 0.08. Ignore the water. I don't have any OH minus to start, and I have 0.02. Now, my feeling is it's definitely going to shift to the right, because really, if you look at this, I have very little of this, and I know it actually is more of an acid than anything else. So minus x plus x plus x. So 0.08 minus x, this would be x, and this would be 0.02 plus x. So now I need my Kb, which if you go back to problem 1b, you will realize we calculated the Kb already to be 7.69 times 10 to the negative 10. And so I'm going to plug this in, these two things, x times 0.02 plus x, and then 0.08 minus x. Now, again, I'm going to ignore the plus and minus x's. So when I multiply this across the 7.69 times 10 to the negative 10 times 0.08 divided by 0.02, just solving for x, I'm going to get x equals 3.076 times 10 to the negative 9. Now that happens to be the OH minus. If I look back up in my ice chart, what that was. So again, I'm going to find the POH since I have no H+. So POH is the negative log of the OH minus concentration we just found. So why don't you in your calculator find the negative log of that while I do it. I get 8.51 is the POH, which means the pH